Okay guys, we're going to talk about comparing fractions today. There are actually a lot of different strategies to comparing fractions. Today we're going to talk about a couple of them. So one is if the fractions have the same numerator. Okay, so if the fractions have the same numerator, let's talk about that. So if I had 3/4 and 3/10, okay? So we're going to decide which one is greater than the other one. So to do that, we're going to actually build these to show how this works. So I have 1, 2, 3/4, and now I need got to find my tenths. Here they are. Okay, so these are my tenths. So this is one whole, right? And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to grab 3 of these. So if we look at this just by size, 3/10 is going to be smaller than 3/4 because these pieces are going to be smaller. If I'm cutting something into 10 pieces, the pieces are going to be smaller than if I'm cutting them only into 4, right? So by knowing that piece of information, we can now tell that 3/4 is larger. Okay, so let's try another one. What if we had, let's do 2/3 and 2/6. Okay, so these are my thirds. There are 2/3. And then these are 6. So we're only going to take 2 of these guys. So these are 2/6. So we can see that this is a smaller part of a whole than this side. So that means that my 2/3 is going to be larger. Okay. So now that we can kind of see that, that would be if my numerators are the same. Notice that this is 2 and 2, and my denominators are the same. So in this case, the smaller the number in my denominator, if we've noticed, the larger the pieces are because I'm not cutting the whole into as many pieces. So since this is a smaller number on the bottom, which seems weird, but my pieces are going to be larger because I'm only cutting this whole into 3 pieces altogether, and we're talking about 2 of them. Whereas with the 2/6, we've got 6 pieces from the whole, and we're only talking about 2 of them. Okay, so that's if the fraction has the numerator that's the same. So then what happens if the fractions have the same denominator? Okay, so if they have the same denominator, for example, let's do 3/5 and 4/5. Okay, so in this case, we're going to build this. These are fifths. Those are 3/5, and this is 4/5. So now if we look at this, because the pieces are the same size, now because I have more of the fifths over here, more fifths on this side than I do on this side, this one is going to be larger. So the 4/5 is larger than the 3/5 over here. Okay, so now let's try another one. What if we had, let's do 1/8. All right, so let's have, both of our denominators are going to be 8. Let's do 3/8 and 7/8. Now think about which one you think is going to be larger. Think in your head which one you think is going to be larger. So these are 1/8. Split all these up. That's 7/8, I think. Let's see. Let's count them. 1, 2, 3, 4, 5, 6/7. Alrighty. And then over here on the other side, we're going to need 3/8. 1, 2, 3. So in this case, we have 3/8 over here and 7/8 over here. So you can see that when the denominators are the same, you're going to look at the top. And this is talking about basically having more pieces that are all the same size than on this side, which has only 3 pieces. So in this case, our 7/8 is larger. Okay, so those are just a couple of number patterns that we can work with when having either the same numerator or the same denominator. Okay, let me find my eraser. All right, now we're going to talk a little bit about how to tell if a fraction is larger or smaller than another fraction by talking about what I call benchmark fractions. Okay, so for this, we're going to talk about a number line. We'll have 0 over here, 1 whole over here, and 1/2 in the middle. So for this, what we're going to do is we're going to think about when we look at a fraction, do we know that it's bigger than 1/2 or smaller than 1/2? And that's going to really help us decide if our fractions, which one is larger. Okay, so let's do 3/9. Do I have, nope, we're not going to do 9 because I don't have 9 pieces to show you. Let's do 3/8 and 7/12. Okay. Now, if we look at 3/8, trying to decide if this is half, what would half of 8 be? Let's think about what half of 8 would be. Half of 8 would be 4. So if we were to build 3/8, this is going to be smaller than 1/2, right? 3/8, if we look at our number line, is going to end up being right about here. 3/8, approximately. So 3/8 would be there. For 7/12, let me find my 12ths. That's tenths. Here we go. Here's my 12ths. So I need 7 of these. So I need, there's 3, 1, 2, 3, 4, 5, 6, 7. Okay, so now before we even put these together, what would half of 12 be? Half of 12 would be 6. So since 7 is larger than what half of 12 would be, that means that 7/12 is actually going to be bigger than 1/2. So 7/12 is going to be just a little bit bigger than 1/2, but it goes right there. So 7/12, just if we think about our number line, 7/12 is going to be larger than the 3/8 because of our number line up there. And we can also build them with our fractions here. But having this 1/2 as a benchmark or sort of a milestone or like a mile marker for us to see where these fractions fall, either higher or lower. Now, sometime we'll talk about how to find them if they are not higher or lower than one high and one low, but that's another lesson. We'll get there, but this is going to be just comparing with benchmark fractions. So let's say I have, let's do 1/2 and 3/5. Okay, this one's a little trickier. Now for this one, we know right where 1/2 is, right? Because it's right here. So we know that 1/2 is here. Now let's think about 3/5. What would half of 5 be? If I had 5 cookies and I was splitting them with me and with my brother and I, then I would have 2.5 cookies, right? So is 3 going to be bigger or smaller than 3.5? It's going to be bigger. So 3/5 would fall right about here. So that 3/5 is going to be larger. Okay, let's try another one. So let's do 8/9 and 1/5. All right. 8/9 is going to be much bigger than 1/2. Half of 9 is going to be 4.5. So 8/9 is actually going to be way over here, really close to 1 whole. And 1/5, if we think about what half of 5 is, that's 2.5. So 1/5 would be way down here. So for this one, we know that 8/9 is larger than 1/5. Okay. Okay, let's try another one. What if we had, let's say we had 5/10 and 1/6. Okay, now 5/10, what's half of 10? Half of 10 is 5. So 1/10, if we think about our equivalent fractions, 1/10 is actually going to be right here at 1/2. So 5/10 is going to be there. 1/6. So if we have 1/6, what's half of 6? 3, right? So 1/6 is going to be a whole lot less than 1/2. So now we can tell that 5/10 is going to be larger than 1/6. So using this number line can be really helpful. And thinking about which one, if there's one that's bigger or equal to 1/2, then that's really going to be helpful. Let's do 7/12 and 2/11. Okay, so what would half of 12 be? Half of 12 would be 6. So 7 is more. So 7/12 is going to be right about there. 2/11. So I know that half of 10 is 5. So half of 11 is 5.5. So 2/11 is going to be way less than 1/2. So 2/11 will be probably right about there. So looking at our number line, we can see that 7/12 is going to be larger. Okay, so this is basically your benchmark fraction approach. So using your number line to try to decide if something is greater than or less than each other is going to be your best bet with this. So what I want you to do now is head back over to our Google Classroom, check out the board notes, work on the worksheet and the fast check. If you have any questions about this, I know it can be tricky. Please stop into office hours. I'm happy to do some more sample problems with you and help you through it. But until next time, I'll see you later. Bye, guys.